here. Okay, so 3 quick reminders. Remember that, and I send the link of today's class with that announcement, but please register with your personal information, at least your name, last name, and the email. Because looking at the data from past sessions, I am seeing some people registering as guests, so I don't know who those are. So it will give me a hard time to figure out who was that in terms of registering the participation in the polls and even in the chat and so on. So please do that when you register with your full name and the email, and that makes it easier for me to register those data. And since I don't have a TA for this class and I have to do all this by my own, it would be a great help from you guys. The second one is related to that, and that is, remember that part of the grades for the class come from the participation, but by participation, it means many things. It means participation in the polls, participation in the experiments that we're going to do. For example, next Tuesday, I'm going to run a new set of experiments with you guys. And it means participation in many domains. So remember that. And of course, there are cases in which you are going to miss class for particular emergencies, family issues, and the like. And I will be alert to those. But the idea to me is to make sure that you are engaged and participating in some of the things that we're doing here. So this is why the first and second bullets here are so important. And finally, a reminder that by February 17 and 19, you are going to write a short piece, maybe a page or less. I don't see this as more than 500 words, on a first rough idea of what you would plan to do for a term paper. So the idea for that paper is for me to evaluate how much you appropriated tools from the course and use them to address a particular environmental challenge, whatever environmental challenge you want. It could be as domestic as in the neighborhood where you live, all the way to Massachusetts, to the US, to another country, to a region, to the planet, okay? And all those scales are fine, because I think, and this is my goal at least, that these tools that we're going to develop in the course, and I will answer that, Catherine, in a second, your question in the chat. These tools are applicable, I think, or at least that's my hope. They can be applied to the very micro to the macro levels, okay? And you will start seeing that, because so far these 2 weeks have been to put in context what we are facing in terms of the political economy of the environmental issues. But having said that, I want you to start thinking of something that you already were thinking of, or you are open to hear suggestions. And this is why Catherine's question in the chat is valid. And with the idea to think from the start, at least from now, how you start making notes of things that happen along the chapters of the course, of the sections of the course, and you think that, hey, this could be useful for my paper. Hey, this could be useful for my paper. And the reason for that is that I don't want you to start thinking about the term paper in 3 months or in 2 months. I want you to start thinking about this now. So let me give you examples, not necessarily ideas, but examples. Examples of things that are controversial and are interesting, I think, and maybe could be interesting for you. Let me give you ideas. Veganism and vegetarianism. This has been posed as a possibility to save the planet, okay? So you hear vegans and vegetarians arguing that by stopping the consumption of meat, we can save the planet, okay? Reasons for those arguments in favor: if you reduce meat consumption, you stop the livestock industry, that on the one hand demands the expansion of the agricultural frontier, and that turns into degradation of forested areas, the expansion of, in the Amazon, the expansion of grassland, and also the expansion of agricultural land to grow corn and soy and other grains to feed animals, porks. I mean, pigs, the pork industry and the cattle industry eat tons of cereals that need to be grown somewhere in lands, and that would increase the demand for land in Africa and Latin America, and that would decrease the amount of forested area and so on. So these are the kind of arguments, but there are also arguments regarding nature. So we have been seeing this a lot with the pandemic. With the pandemics, with the idea that as humans are getting closer and closer and closer to nature, increases the possibility of getting humans in contact with parasites, with pathogens in general, that transmit diseases that are very harmful to humans. And COVID is one of those examples, and most likely came from close contact between humans and bats, which could be a case. It could be another animal, but these are wildlife that are self-contained in nature, in pristine ecosystems, that if humans begin to push the frontier against conserved areas, they are going to get closer and more likely to get in contact with pathogens that will harm humankind. Okay, so that's another argument for people along the vegetarianism and the veganism movement to stop eating animals and then stop other kind of harms that affect human livelihoods and the sustainability of Earth. On the other hand, and this is why this is not that clear, on the other hand, producing vegetables requires also land, and not only land, but to be able to supply the protein intake that humans need to replace meat, which is a high level protein content food, with vegetables, you will need to grow way more vegetables to supply for those needs for humans, and you will need to use tons and tons of pesticides and many other agrochemicals that could be as harmful to the environment because of the use of chemical pesticides, to be able to supply the amounts of vegetable food, non-meat based food, to satisfy the needs of humans for food. So these are pros and cons of these ideas. So that's an idea. Is vegetarianism and veganism a solution to environmental problems? And I am not saying I have a firm, clear answer, and I don't think science has still figured this out. But it would be an interesting idea for this course, because that would require that you start thinking about this. Maybe you have your priors. Maybe some of you are vegans or vegetarians for one of these reasons that I have said, but maybe you're not. But it would give you an opportunity to dig into the literature, to dig into the data, and then try to argue and write an essay in your paper with the pros and cons of why is it true or not, or to what degree is it true or not, that veganism and vegetarianism are a good idea to save the planet. Okay, so that's one idea. Let me give you one more idea. Electric cars. This is another tricky one. Yes, producing and using fuel-based cars, fossil fuel-based cars, definitely has a huge impact on the environment, emissions. And we know this because the oil industry, the fossil fuel industry in general, along with the auto industry, they have played an important part in the production and consumption of fossil fuels that have increased the amount of CO2 into the atmosphere. So moving to electric cars in general might make sense, right? But there are other things along the way. For example, batteries. So if you Google later, and I think I mentioned this before, if you Google later, the Congo Republic in Africa, which has huge deposits of cadmium and lithium that needs to be exploited at way larger amounts to produce the batteries that are needed to run an electric-based auto industry, that opens up a whole new dimension of complexities of what I'm talking about. And once again, I'm not going against or in favor of moving to electric cars. I'm just saying that this has economic consequences in many domains because of the ecological consequences of doing this technology transfer. The electric industry and renewable energy production depends a lot, and this is connected in another domain. It's related to solar power and wind power. In that case, think about the major difference that happens when you shift from having the energy containing a liquid, let's call it gas, that you put into motorcycles, cars, trucks, and the energy is contained in that liquid that you put into the tank and you use it, you burn it. Now you need to put the energy into a battery, but also you need to fill up the tank, quote unquote, to fill up with electricity that battery. You need to transport that battery, and transporting battery needs lots of metals, and in particular copper, because copper is very useful and efficient to transmit energy. Therefore, the mining for copper is going to be increasing probably in the coming years. And if you look at the stock prices or the commodities prices right now with lithium, copper, and the like, you will see very interesting things as the auto industry, as you have seen in the news, continues to announce that this is going to shift towards electric cars. So the major brands are now committing to say in 2030, in 2040, in 2050, we will be to this amount of our fleet to be completely electric cars based. So that's the kind of examples that I'm trying to provide here. Now, these are challenges to solve with a simple sentence like veganism or vegetarianism is going to save the planet for these and these and these reasons, and there are the pros and cons of that statement. Or shifting to electric cars is going to be good for the environment for these and these reasons, and then again there's the pros and cons. With those two examples, and again these are examples that you might find interesting or not, but with this I want to invite you to think of many other possibilities. Here comes the final answer to that question. The political economy of what I just said. Because as we will be working throughout the course, we will be always talking about the winners and the losers of technological changes, the winners and losers of a particular measure. Let's say a carbon tax. Carbon taxes are today probably one of the very few political economy ideas, or let's say one of the few economic ideas that have a broad political consensus in the spectrum. I mean, there you can find very conservative to very liberal or even leftist economists who agree that a carbon tax could be a good way to tackle the problem of global warming. Yet, implementing any of these things through cultural change, through taxes, through legislation, you name it, will have winners and losers in many ways. Winners and losers of the proceeds from that change, from the ecological consequences of that change, from the social or economic consequences of that change in terms of labor markets, in terms of education, in terms of exposure to environmental harms. So these are examples of things that are anyway, in any of these cases that I have mentioned, will imply thinking about the tools from the class, the tools that we're going to be using, and how we can apply them to these particular challenges. Now, these that I have mentioned are quite, let's say, global, in the sense that they may apply to many countries, but there are other cases in which you may find a particular problem that could be locally based or located geographically in a particular place. Again, a neighborhood, a district, a county, a state, the country, many countries that could be as equally interesting, even if they are contained only to the particular case. Okay, so I hope that I answered with that long answer Catherine's question, and with that, let me ask if there are other questions regarding this idea that you need to start thinking. But again, this is going to be basically one page, 500 words or something of an idea of something as broad or specific as you are beginning to think or you have been curious. And then I will give you feedback on how that could be an interesting idea to use for your term paper that you are going to be working in the semester. So any other question on that regard? And thank you, Catherine, for that question. Anyone has any other question on this? Okay, so with that in mind, because we have been talking about these different issues, let me come back to this map with which I concluded last time, again to raise the issue of how heterogeneous the planet is, and I'm going just to show you a few more pictures of this kind. But here, what I was stressing is that imagine how different are the needs of these people concentrated in certain areas of the planet, the aspirations of these people, the levels of development of these people, and therefore the need for the planet to supply with the matter and energy required to offer these 7+ billion people on Earth with what they need. Okay, and that's basically the point. And I wanted to start with people, because with this map you see where people are spread out in the planet quite unevenly in many senses. So here's one more picture that probably is going to be very small in the letters, but I'd like to use this just to show you a few contrasts in, if you think of this map here, when you look at these few numbers. So let me give you a few examples here. So I'm going to use this laser point. So the idea is this one with this graph, which is a nice summary of the world. If the world was composed of 100 people, who would those people be? So we know that we are pretty much 50-50 male and female, right? In terms of age, 26 people would be children, 74 adults, and 8 would be adults over 65. In terms of religion, it would be pretty much spread around major religions: Christians, Muslims, Hindus, Buddhists, and other smaller minor religions. 12% of those people, or 12 of those people, would have declared not to have a religion. In terms of literacy, 83 of these 100 people would be able to read and write, and 17 wouldn't. In terms of information and education, we would talk about 7 people having a college degree out of those 100, and 22 would have access to a computer. So that gives you an idea. And then let's talk about other issues about the material well-being. So in terms of nutrition, 21 people would be overweight, 63 people would be with adequate nutrition, 15 people would be undernourished, and one person would be starving. Okay, so here when we talk about nutrition and food, it comes to these heterogeneities and inequalities that I was mentioning. In terms of water, 87 of those people would have safe drinking water, and 13 people wouldn't have that. In terms of housing, 77 people would have a place, a roof, shelter, and 23 people would not have that, would not have a shelter. And then if we think geographically where they are located, in terms of continent, 60 of those people would be in Asia. That relates to the previous map. 15 people would be in Africa, 14 people would be in the entire Americas, North, Central, and South America, and 11 people would be in Europe. Okay, and in terms of language, basically 12 of those people would speak Chinese as their main language, then 5 people Spanish, 5 people English, 3 people Arabic, 3 people Hindi, 3 Bengali, 3 Portuguese, 2 people would speak Russian, and 2 people would speak Japanese, and 62 people would speak many other languages, which is quite interesting to see the diversity of languages in this sense. Finally, when we look at this chart, it shows how the Earth's surface is distributed. And I like to put these two along, not because they are nice circles, but think of the following two. This is basically water and ice. And that water and ice in the planet has some interesting features. One of them is all this portion of the Earth's surface is in international waters. We're talking about 43% of the Earth's surface and 95% of its volume. And this is an area that we would call lawless part of the planet, of the ocean. By lawless means anyone can go there and whatever, and they can do whatever they want in there. Fish, dig, pollute, because these are water areas that are not within the sovereign states. You know that each country has access to the ocean has rights over a portion of water around them. I don't know what exactly it is for the US, but for example, for Colombia, it's pretty much almost the same area that Colombia has in land. An equivalent, almost equivalent, Colombia has in sea area, sea territory, in which Colombia has rights, control over that portion of surface. But all this is open access, and we will be talking about that later in the course. What does it mean to be open access? But for today's discussion, it's very important because it means a particular set of property rights that are not private, nor state, nor communal. They are just open access. That means anyone can go there and take whatever they want. And this is going to be important because probably no, this is well documented. In all this territory that we see here, many ecological processes in terms of the production of biomass, in terms of the regulation of the atmosphere, and I will mention that in a second too, are key to sustain the natural capital stock of the planet. And yet, they don't have any particular institutional arrangement, except that if you have a big boat to be able to sail around there, you can just go there and do whatever you want. Okay? Now, there's other part in terms of water that, let's call it, belong to the countries, where countries with their navies, depending on their capacity, they can come in and control and exploit and explore and extract mass, biomass or energy. Some of this has to do with ice caps that are shrinking, as we know. And then this is the territorial, let's say, land surface. And here we have Russia, Canada, China, and the US as major territories, these four here. Brazil is also a huge one, Australia, and then this whole bunch of countries and countries and countries and countries. So Colombia actually is tiny, tiny here, and it says Colombia has 0.22% of the Earth's surface. And yet, Colombia is probably host today, according to estimates, to somewhere between 10 and 15% of the world's biodiversity. Birds, if you are a bird watcher, you like birds, this is the place to come. In terms of biodiversity of birds, Colombia is top one, first place. So this creates very interesting things in terms of the heterogeneity of endowments of natural capital that countries have in this land portion of the planet, then this lawless ocean area, and then these other oceans that are subject to certain institutional rules. Okay? Coming down to more specific environmental problems, let's talk about one that is key to sustaining the economy and life, water. So some experts have been exploring the problem of water stress, and by water stress, it could mean the idea that the country will have a problem by 2040 to supply the needs for water for its population in its country. And this means that the provision of water for human consumption, for agriculture, and for the industry, and to sustain the ecological processes that the ecosystems in that territory need. And you see here some countries that are having some challenges in terms of water stress, countries that are in dire situations in North Africa, Sub-Saharan Africa, North Africa, um, in the Middle East, and some of these countries, even some parts of Eastern Europe, Asia in general, India, Nepal, Bangladesh, China, Siberia, all these areas are also having serious challenges to provide the water they need for so much population. So imagine in China, if they're building one new city every now and then, that whole new city requires an immense water supply system with potable water. And that means you need to get that water from somewhere, either the aquifers or surface area from watersheds. So it's huge challenges. Australia too, South Africa too. Okay. Uh, in general, Latin America, especially Central America and South America, are not in those cases of stress for water, except probably Chile, which is here in the coast. And there are geological reasons and geographical reasons of why is that. But in general, and Peru for a certain extent, they have some issues with water. But in general, South America has a good fortune of having a good supply of natural supply of water to provide for its needs. And yet, I'm going to mention in a few minutes an example of why we shouldn't just relax and not think that this is going to be problematic. Same for some of these countries in the middle of Africa, in Central Africa, that today would look like they have low levels of potential water stress, and yet they're going to be having some troubles in the future because of the changes in the policies that determine the coverage of forest. And finally, um, this other map will show even the heterogeneity within countries, because here we see the US here as a country that in general may have a high level of water stress, right? But if we look in detail in the US, you can find places that in terms of water stress are not problematic at all. So if you look at New England is okay in general, and the East Coast in general is okay. The West Coast has some serious challenges. We know this. California has serious problems with water. And you know why this has created water markets. You saw the news a few months ago. There was this big debate in the press on whether they were creating markets for water. They actually were not creating markets for water. They were creating markets for futures of water in Wall Street. It is related, but it's not exactly the same. And some places that are in serious problems in terms of water stress. Okay. And the same if you look in Europe. Europe in general, if you look here, is doing more or less okay. Spain has some problems. But when you look into the detail, you can see in certain regions in Spain, for example, right here, you can see some places that are in more dire situation in the south of Spain, whereas in the north of Spain, it seems to be more or less okay. So this is just to say that these are major heterogeneities of endowments and needs that need to be solved. And in all these, what we are doing today to wrap up this idea of how the market economy and the capitalist revolution transformed the surface of Earth in many dimensions, and one of them in terms of biodiversity and conservation of water and conservation of forests and conservation of the atmosphere. And here I want to go back to the idea of the market economy, because a major theme in the capitalist revolution has been the emergence of markets that didn't exist at that scale in the ancient times. I'm not saying there were no markets. Of course, there were barter markets. There were just small trading markets that existed here and there. But the scope and the size of the markets that we're seeing today are quite remarkable to what we're trying to do and to understand what is happening here. So let me jump here to the next, and hold a second because my computer now is doing something strange. Whoops. Hold a second. Wow, this is not nice. This is not good. Let me stop here. Can you see my screen? Look what happened. I don't know what is happening here. Give me a second. Let me actually stop here the record. Okay, here we are. So what I wanted to do is to connect markets with this. And I'm going to read you. If you read Spanish, you can read the original in the bottom left. And here's the story. In 2017, November 6th, I think, hold a second. Did I share this with you guys about this Facebook posting? No.
No, we can't see it.
Yeah, I was gonna say, is it supposed to be in the chat or on the screen?
Uh-oh. So you're not seeing my screen yet?
No.
All we can see
okay.
is you.
Ah, okay. Wait. Here. Okay, now you should see it, right?
Yep.
Okay, so I didn't tell you in the past about this Facebook posting that I did 3 years ago. So this is kind of curious. You probably guys remember there was this thing called Facebook that it's now fading away in importance. It used to be pretty intense. So in 2017, I posted this and I was saying, if I teach again my introductory course to microeconomics, this is how I'm going to start my class, my course, the first day of classes. And I wrote the following in English. So this is a free translation. So I want you to read it. Okay, you read it now? So here's the thing. I found this again a few weeks ago. And I swear, I don't remember if I wrote this short story or if I found it elsewhere. I've been looking up in Google many times and I haven't found anything ever close. So it could be the case that I made it up. And I think it's a cool story, but I'm not going to claim authorship yet. I'm just saying I haven't found if this was written by somebody else, and I just found this that I posted this in Facebook several years ago. But the idea, you get the punchline. So markets do very interesting things, and markets do things that sometimes are unintended. And these kind of things that are unintended are going to be sometimes surprising and problematic. And with this story, I wanted to do that, to give you an example of what markets can be doing in that sense. Okay. Rip turtles. Okay. So here's the thing. Because I cannot claim authorship, let's say somebody made this up. And if you guys find this, because this is my free translation from the original in Spanish, and the original, by original, I mean what I posted in Facebook. I just wanted to raise attention to this. I mean, this traveler had very good intentions. And this traveler said, I want to save the turtles. So I'm going to buy them and release them. And you just saw what markets do. Okay? And this is important to what I'm trying to argue in the remaining of the class, because I want you to think back about the experiment we did the first day of class. Okay? Because in that experiment, if you remember, there were 13 of you who were sellers. There were 13 of you who were buyers. And you had the intention, it was not mandatory, you were free to do so, of trading with cars. And if you remember, you were assigned the role of seller or buyer. And if you were a seller, you were assigned certain costs. And you were assigned, if you were a buyer, you were assigned certain values that for buying that car, and then you were up for the trading floor and free to do as you pleased. There was no regulator, if you remember. There was there were very basic rules about the trading, and basically you had your incentives, your own incentives. And the only thing I said is you are free to trade whatever you want, up to 3 units each of you, and we will see what happens. And I included an incentive that I mentioned, which was I am going to accumulate these earnings from these experiments and the experiments from next week and so on. And at the end, and if I am able to make it to Amherst on time, I will make sure that some of you randomly chosen get a present from me of equivalent monetary amount, let's say proportional amount, given my budget, my personal budget, but I will choose randomly some of you, and the more money you make in these experiments, the better is going to be the gift that I'm going to send to a couple of you, okay? And that was it. And I ran that experiment, and you saw the results, which are on the screen. But also remember that during the first 3 rounds, this was, we could call it business as usual, a traditional, conventional supply and demand curves that are supposed to create incentives for trading in a market. But then in the rounds 4 to 6, I said, hey, we have a little problem, climate change. So every car that is traded in this market is going to impose 10 cents of cost to everyone, to each and every one of you, because the more cars are produced and the more cars are consumed and used, the larger are going to be the emissions into the atmosphere, and therefore the greater are going to be the environmental costs coming from climate change. Because this increase in the concentration of these emissions in the atmosphere increase temperatures of the ocean, and that increases the amount of water that hurricanes are transporting and deploying in land, and creating hazards, disasters, floodings, displacement of people, problems with health, with attending people affected by these natural hazards, and so on. And I did this in advance of every of those rounds 4 to 6. And we continued the market. And the market, in many ways, in those rounds, which are the red dots in the graph, basically showed that business as usual continued to be business as usual. If anything, there was a slight increase in prices of some transactions, and I have an explanation for that I explain in a second. But except for that, pretty much the same number of cars were traded, and I'm going to show you the numbers, and I'm going to send you the numbers to think about it. So cars continue to be produced and consumed, or demanded and supplied. Transactions continue to happen because the market provides these incentives for these things to happen. But you were facing these costs. You were paying out of your earnings the mitigation and adaptation costs to climate change. And yet you voluntarily continue to trade. You continue the transactions. And that's part of this idea of thinking about the role that markets play in environmental degradation and what are we going to do about it. The only reasons prices started to go up, and in fact were a little bit above of what would be exactly the $5 benchmark in the graph that you see where supply and demand crosses, is because when you guys entered, I set up the experiment for 13 sellers and 13 buyers, which was the whole roster of you guys registered. But actually, only 13 plus 8 people, 21 people showed up for the experiment, and the buyers' positions were filled rapidly, and then only 8 sellers. And you can think from a basic economics that less sellers gives those sellers more market power, and therefore if those sellers have more market power, because there is a little bit more demand than supply, prices tend to be a little bit higher, and that's exactly what we see in the data. But that's that. So if I actually were to build the final effective supply and demand, that's exactly the graph that you see below. So if I put that graph in terms of the scales of the prices, you can see there quite clearly that if you look here, if this is the market price, the equilibrium market price, that's pretty much where most of the trading was happening there in the market. But the punchline, it's not necessarily that this was according to the theory. It's the problem with these transactions, because these transactions continued to happen and you knew you were paying out of your earnings, of your profits. You were paying the costs of mitigating and adapting to the environment. And we discussed that the first week, and in the recordings of the classes, you can see that. So if I am going to put all together all that data, and I'm not going to show you all these details that you see there, but these are the numbers for the sellers and the numbers for the buyers in terms of how many people were trading in each of the rounds, how much was their average earnings in those rounds, and how much was the dispersion of those earnings, because there were people who were making more money than others, and so on. And the same for the buyers. And I look at the market prices in terms of the minimum prices that were being paid, the maximum prices, the average prices, and the total number of units being traded. And here's where I want you to pay close attention. So the first rounds, we were trading somewhere in between 13, 20, 21 cars. The first round is always slower while you get a hold of how the platform works in terms of the trading of the market. But then you were trading 20, 21 units. And then the climate change started. And then you were still trading 18, 20, 21 units. So remember that each of you had to pay 10 cents out of your profits to cover your own costs of mitigating and adapting to the climate change. So those 10 cents multiplied by these 18, 20, 21 cars, multiplied by the 21 of you, created net losses for society, right? And those are these gray bars in the graph in the right. So the yellow bars measure the well-being of society in terms of the sum of the net earnings of the buyers and the net earnings of the sellers. This is what in economics we call the producer surplus and the consumer surplus. So we add those up. Why I want those yellow bars? Because this is what capitalism does. It creates value. Because of this market, these yellow bars were high enough, and also they were increasing because you were learning to compete and to trade in the market, and that was producing surplus to you guys, to buyers and sellers. But in round four, we starting accounting for the costs to these countries, and the amount of social costs because of the climate change created by the market transactions are these gray bars, and they accounted for quite an amount of the total earnings. So at the end, if you think of net for society, what was being produced is only this part, because those yellow bars are the gross well-being, let's call it, if we measure in dollar amounts, minus the social losses that you each had to pay to attend the costs of mitigation and adaptation to climate change. And that was the point. And again, you were quite aware of this. You were paying out of your pockets these gray bar costs. And yet, it doesn't look like the market was going to change in terms of the pattern of production and consumption. And I hope you make the connection with the story of the turtles and the markets. Okay? Now, with that in mind, there are big questions here. And we discussed some of those in the first class, in the first two classes. One of them is this efficient? I mean, here, in terms of efficiency, it's good that we're going up in these 3 rounds, because that means that the market is disciplined through competition, is disciplining the actors in the market. Basically, what was happening in this trend here is that you were learning to compete. You were learning to make trades. You were seeing who was offering more and less. And we saw how the prices were converging towards the market equilibrium. And this is the first theorem of economics, Ken Arrow, who said, and this is the invisible hand story of Adam Smith, by individuals pursuing their own self-interest, participating in the market, the aggregate of society is going to benefit and gain all. That's good for these 3 rounds. But once we account for this problem here, things begin to get tricky. So in terms of this question, is this efficient? Yeah, it was efficient in the first 3 rounds, but it's not as efficient in the next 3 rounds, because we think that the market by itself is going to regulate and maximize and optimize the well-being of society, but at the same time, those same market transactions and market forces are going to create all these losses for the same people who are making the decisions in the market. And that's the paradox that I want you to understand. And this is exactly what is happening today at the planetary level. And this is why today boards in the major companies are finally beginning to come to terms with this problem of those gray bars in the right. When they begin to see that this is not efficient, that to be efficient, and if we account for how much extra we are needing to pay to cover the costs of environmental degradation, this costs money. And that's about efficiency in itself. But there are more questions. The other one, is this fair? And we discussed about this the other day when we were debating the experiment. And I remember a couple of you saying, this is kind of unfair, because some countries, while trading in the market, were thinking, okay, if I trade more, I'm causing more harm. What if I decide unilaterally as a country to stop consuming cars or to stop producing cars, but the rest of the countries continue in the market participating, and I am going to still suffer the problems of climate change? Why should I bear the costs of the actions of others? So in that sense, many of you were saying, it's probably not fair. And it's not fair in the dimension, in the same moment of time, for those people who are deciding on their own whether they want to contribute or not to the problem, and yet they have to bear the costs because of others creating the problem. And finally, is this sustainable? And no, it is not sustainable. Why? Or that's the argument regarding the discussion of climate change, for example, because it's a problem also of fairness with the future generations. So if we do this today, at the trend that you see here happening in the experiment, in the simple replication of what we did that day, over time, and this is a point that I want to make sure that you keep in your mind of today's presentation, over time, the planet is not going to be able to maintain its natural stock to provide the goods and services that society needs, and especially with a growing population. And we will be soon hitting the 10 billion people on Earth. And that in itself, it's creating even more demand. And if many of those billions of people are improving their standards of living, they are aspiring to better levels of consumption. And all that together is creating more and more stress on the capacity of the planet to provide for the goods and services that those people need. And that's exactly the point that Ken Boulding was doing in the text that you read, that is 50 years old and continues to be so much relevant. And I put in the Moodle a reading that wrote Ed Barbier and Joan Burgess that I mentioned 2 days ago, that I invite you to read, because there is even mention of what we know today of those huge costs for society for not incorporating into the macroeconomic accounts the losses of the capacity of Earth to sustain itself over time with the current economic models. And this sentence that Boulding made that I mentioned before, it's an interesting and provocative statement for that. But to get into detail of that is to come back to this idea of the planet as a spaceship Earth that contains these 7+ billion people who are navigating in this closed system. It's a closed system that, yes, indeed, the closed system has inputs of solar energy from outside, and we are trying to make more and more better use of that solar energy to replace how we produce energy from fossil fuels. Yes, it releases energy, but that energy releases of low quality because of entropy, the second law of thermodynamics. But in the inside is the economy, and that economy is using up energy and material from that spaceship Earth and releasing back degraded material and degraded energy into the same ecosystem. So the argument that Boulding and Herman Daly and other of these scholars of the ecological economics movement were saying, this is fine if you look in the right, this is fine when you have an empty world. This is, in other words, the cowboy economy that you read with reading Boulding. But there was a time not long ago that we thought that there was enough timber for everyone, that there was enough oil for everyone, that there was enough clean air for everyone, that there was enough water sources, natural water sources for everyone, that there was enough game for hunting and providing meat for everyone. But as the economy began to grow and grow and grow, and this is the sentence of Boulding that you read there, we came now to a full world. And this is where the spaceship economy, the spaceman, I'm sorry, the spaceman, let me put it correctly here. I don't know why it has to be spaceman. It could be spacewoman economy. Actually, it should be spacewoman economy. And maybe we would be in better hands now. I mean, it's well proven now that women leaders are making better decisions in boards, in big companies, in financial institutions, in governments, with the pandemics, and so on. And that's the problem, that this box is huge now, and it's filling up this closed system, okay? And that's a major challenge today. And again, 50 years later, this is why it's so relevant, this text by Ken Boulding. So with that in mind, let me make here quickly a poll that I have here with an analogy that I did last time, and see if you remember this. I forgot to resume the recording. Okay, so it looks like only one person has seen it. Who is that? Who have seen it? Who has seen it? Who is it? Okay, one of you said that you have seen it. The rest of you haven't seen it, which is great. So I'm going to do the following because I am running out of time and I want to devote the last 5 minutes in a few points. I'm going to, before you leave, I'm going to share it in the chat in Zoom. The video is about 4 minutes, 5 minutes, but it's beautiful. I want you to really listen to it. And in fact, yeah, I'm going to put it right when we finish. I'm going to put it in the chat for you to watch it because it's a beautiful video. So, okay, it looks like somebody already did in the chat. No. Okay, so I'm going to share that in the video because it's a really beautiful video. But let me move to the point about how everything is connected. This, I'm going to leave it in the notes for you. This is a beautiful animation that you can move here in this link that you can generate in this link, which is the Earth in motion in terms of the flows of winds and water around the world. And it gives you a sense of the message that I'm trying to communicate here about how everything is interconnected. But let me give you 3 examples of that that are really fascinating of what we know today from science. One is, today, sunlight that is falling into the ice caps and especially in the Arctic has been clearly connected with the temperatures in the Pacific Ocean elsewhere in the world. In other words, the fact that we have these white surfaces, quite white, brilliant surfaces, reflecting sunlight back out of the earth, as opposed to land area, deforested area, degraded area without the ice caps that absorbs the sunlight, that is changing and increasing the temperatures of the Pacific Ocean, because the sunlight is not being reflected back from those ice caps. So this is why it's so relevant, the depletion of the ice caps, because that surface in those amounts is important to maintain the temperature of Earth. So that's one example. The second example is how scientists have been proving that there are major wind forces that pull up sand from the Sahara in Africa, and that sand is transported throughout the Atlantic and deposited back in the Amazon in South America. And that sand from the Sahara in Africa brings nutrients that are key for the productivity, the biological productivity of the soils in the Amazon. And therefore the importance that the winds that move from Africa through the Atlantic to the Amazon work well to transport the nutrients, the chemical nutrients, mineral nutrients from those sands in the desert to feed the productivity of the soil in the Amazon, which is quite thin and quite fragile. And finally, those forests in the Amazon capture humidity and water, and because of the winds, they release back the humidity and the water, and the winds from the Amazon to the Andes bring water to the Andes, and this is what is called the flying rivers. And again, I'm going to give you one link of a beautiful animation on how the water is transported through the air, through the winds, from the Amazon to the Andes and to South America to provide the water needed for the supply for agriculture, water consumption, and the like in the rest of the continent. And this is all determined by the amount of forest that is preserved in the Amazon. The less forested area, the less capacity it has to retain and then release water, so that the winds transport that water and bring it to the Andes and to hundreds of millions of populations in Central and South America that depend on the water that is coming from those flying rivers. Okay, so I am going to leave there, and on Tuesday, I'm going to come back to the idea of the capitalist revolution, on how the social interactions with and through the markets create certain consequences for the individual interests and for the collective interests. But I wanted to finish, to complete here quickly with a quick poll of, I think it's just 3 questions, based on your reading of chapter 1 of core. So it's just 2 questions, just quickly these 2 questions, so that I can take a look at what you are interpreting from the readings. 30 more seconds. Ten more seconds. Okay, I'm going to close this in 5, 4, 3, 2, 1, and that's it. Okay, so it seems to me that looking at the answers, and by the way, I'm always compiling these questions and answers. I'm going to post them in the Moodle so that you come back to those and see, wow, I was lost, or I didn't read enough, or I didn't understand. So for you to look at those, so I'm going to keep those back to you in the Moodle. But let me just say that it looks from the answers that some of you may need to take a look back at the chapter, because this chapter is key to close this second week so that we can start next week with a new chapter that we're going to be reading, which is chapter 4 in the book. So what I'm trying to say is, if you haven't finished up your reading of chapter 1, do that today or this rest of the week, because you are going to start reading for Tuesday the first part of chapter 4, which is key, and because we're going to be running some experiments on Tuesday and Thursday to continue with that. So I'm going to stop sharing my screen there and just say that pay attention in Moodle. I will be sending you more instructions of what is coming on for next week. Just write down that you're going to start reading chapter 4. Wrap up your reading of chapter 1, because we're going to do the transition on Tuesday on why the capitalist revolution had to do with these issues and how it brought then the environmental degradation consequences that we have been talking. So that's it for today. I hope you guys have a warm and good weekend. It's good to see you, especially those who turned on your camera. It's good to see that Michelle is not driving. That scares the crap out of me. So you're not driving. I'm glad. And thank you for coming to class. I hope I see you guys on Tuesday. And keep up with thinking about the ideas for your essay, for your term paper, and with the readings. Okay. So see you guys soon, and have a great
Thank you.
weekend. Okay. Good to see
Thank
you.
you.
Thank you.
Bye bye.